Now I will just write down those values and observed frequency, expected frequency, and show how we can compute chi-square test statistic, okay? So here I will write down another column will be the difference between observed frequency and expected frequency, which will equal Fij subtract Eij, right? We use 40 subtract 50, so -10, -5. This is equal 55 subtract 50, right? 5, and then 60 subtract 50, 10. 50 subtract 50, 0. So this one shows the difference between observed frequency and expected frequency. Now I will add another column, okay? So this column here will shows the square, okay? So Fij subtract Eij square, because here we have the square, right? So I will just write down the square of this difference. -10 square will equal 100, -5 square equal 25, and then 25, 100, 0. Then we should use this square divide Eij, right? So Fij subtract Eij square divide Eij, okay? So based on this, we should use this column's number divide this column. So 100 divide 50 equal 2, right? And then we have 25 divide 50 equal 0.5. 25 divide 50, similar, 0.5. And then 100 divide 50, 2. Finally, we have 0 divide 50 equals 0. And then go back to check our chi-square test statistic is the summation of this final column, okay? So here, the summation of the final column will equal, we take the sum, okay? So we take the summation, it will equal 2 plus 0.5 plus 0.5 plus 2 plus 0. So finally, we have 5. So this 5 here represents for chi-square test statistic. Okay, so that way we can obtain the test statistic. Okay, so this is the part B. Sorry. Now let's look at part C. So part C wants us to test this hypothesis at the level significance equal 10%, and then hope us to determine the critical value from the table. Therefore, let me just write down if that alpha represents for level significance, okay? Level of significance. Then we will have this alpha will equal 0.1 because we want to test this hypothesis at 10% level significance. And we also have our K sample size. Oh, sorry, K equal to the population size, right? So 5. Therefore, based on the chi-square distribution, we will have the degrees of the freedom df here will equal K minus 1, which will equal 5 minus 1 equal 4, okay? Then we need to first find out a critical value at 0.1 if degrees of the freedom equal 4. Okay, so let's go back to the chi-square distribution table and find out this value first. So what we need to do is to use this chi-square distribution table. You can notice this shows the chi-square distribution table, right? First, we need to find out degrees of the freedom equal 4, okay? And then we need to find out the level significance. So the level significance equal 0.1, right? So this is the chi-square number if the level significance equal 0.1 and degrees of freedom equal 4. 7.779. Okay, so let me write down this critical value first. 7.779. Okay, so this is the chi-square number at the level significance equal 10% and the degrees of freedom equal 4. Now let's look at part D. So part D says, what can we conclude about the fairness of this lottery? We now have the level of the significance equal 10%, right? And we also have our chi-square tested equal 5 and the chi-square at level significance if degrees of freedom equal 4. This one will give us this chi-square equal 7.779. And if you still remember the rejection rule based on the critical value approach, okay, so we'll reject the null hypothesis if the chi-square test larger or equal than chi-square at level significance. However, in our question, we notice we have 5. This is the chi-square test less than 7.779. So we cannot reject the null hypothesis. We cannot reject the null hypothesis, and that means there is no evidence. So we can get a conclusion, okay? The conclusion here is there is no evidence that the lottery is not fair. So this is the conclusion that we can obtain based on the critical value approach.